Hello everybody, and welcome to Chapter 11, Section 1, Properties of Rational Numbers. In this chapter, you'll be learning about rational numbers, and those are real numbers that can be expressed as the quotient of two integers. Basically, another way to say this is anything that can be put into a fraction, almost anything, is a rational number. There are some exceptions, things that once divided and have a repeating number after the decimal. Those are not rational. Those are called irrational. So those do not apply. However, I'm going to give you some examples of what I'm talking about. Basically, any whole number can be written as a fraction, including the number 0. Well, how would you write 0 as a fraction? You really just put 0 as a whole number, and you know that any whole number you can put over 1. Here's another example. 7, you could rewrite that as 7 over 1. And you can do decimals. 0.43, you can be written as 43 over 100. Here's another example. If you were given a percent, let's say, I don't know, 60, I already have a 7 there, let's do 72%. You could write that as 72 over 100, which equals a fraction. So what I'm going to do is I'm going to translate what the textbook is telling you into these notes so that you have an easier time figuring out how to do your homework. So example 1 tells you to write as a quotient of integers the following. Write as a quotient of integers, which basically means, as you know from reading the notes that I sent you, basically means write it in fraction form. So if you were given -1 4/5, that's called a mixed number. It's not quite a quotient just yet. A quotient can only have a top and a bottom. It cannot have anything on the side. So what you need to do then is, we've talked about this before, but you would multiply the denominator times this. So that would give us 5, or really it's -5, and then times that number by 4, so we would get -20 over 5. And that would be written as a quotient of integers. So that one would be all set. If we were given a percent, we kind of did this one earlier. Let's say we were given 48%. Well, you could write that a couple of ways. You could know that it's a percent and it goes right over 100. Or you might say that could also be like this, is represented in decimal form, and then eventually it would be 48 over 100. That's just going through all the steps. You don't need to do it that way. You could skip right to this point and it would still be correct and fine. Anything you could be given. Let's see. What's another one? The book gives us 0.6. 0.6. And we know that because this is in the 10th spot, that we're going to put 6 over the number 10. And that is a quotient of integers for that number. So that's all you're doing when you're given different kinds of numbers. You're putting it into fraction form. Okay, for example 2 in the book, they ask you the question, which fraction is greater, 8 over 3 or 17 over 7? If they had the same common denominator, it would be really easy to tell which one is bigger, but because the denominators are both different, it's hard to tell just by looking at fractions which one is bigger. And sometimes the one you think might be bigger could be wrong. So there is a solution for this. The first thing that you're going to want to do is find the LCD. And that means least common denominator. We talked about this in the last chapter. So what is the LCD of 3 and 7? Well, they are multiples of the number 21, which is the smallest or the least common denominator. So it's 21. So what we're going to do then is we're going to change the denominator for each one of these fractions up here to 21. 21, 21. So how do we get from 3 to 21? Well, we multiply the bottom by 7. That means we multiply the top by 7. So 8 times 7 is 56. And so we have the first fraction. Now we have, over here, we have 7. How do we get from 7 to 21? Well, we multiply that by 3. So we're going to multiply the 17 by 3 as well. And 17 times 3 is 51. So now we can see which one is greater. And so the one on the left is greater, so we are going to put a greater than sign. Or the alligator is going to eat the bigger fraction, is how we say it in a non-technical way. So then when you're trying to get your final answer, what you're going to say is, once this work is all done, you can then say this little 3-dot thing means therefore 8/3 is greater than 17/7. Awesome. Okay, so the LCD method is one way that you can figure out which fraction is bigger than another. Another thing that you can do, there's another property of quotients that I want you to learn that the book tells us about. And that shows us that when you have two fractions, which is what's going on here, represented by A, C, and B, D, so they just represent two different fractions, what you can then do is you can multiply across, and if A times D is bigger than B times C, then that means that this first fraction is bigger. So that's pretty cool. And the next one says the exact opposite. So if A times C is bigger, if A times D is bigger than C times B, then the other one is bigger. Then that means that BC is bigger. So to see that in action, I'm going to do I'm going to do an example from the book. So they have 4/7 is greater than 3/8, they say, because 4 times 8, which they're multiplying across, put it in parentheses, is bigger than 7 times 3. And are they right? What is 4 times 8? 4 times 8 is 32, and 7 times 3 is 21. That's correct. So that means that this first one is bigger, and that's why you put the greater than on this side. So that's another method that you can use to figure out which one is bigger. So for example 3, we're going to use the property that we just looked at on the last slide. The directions say replace the question mark with either less than, equal to, or greater than to make a true statement. And then you have two different fractions. You have -5/8 and then you have -7/13. So we need to figure out which one is bigger. Well, just one really quick note that the book shows you is that when you have a negative sign in front of a fraction like this, generally you just put it on the top, or the numerator. It goes with that. And then we're going to change this one over here to be on the top as well. Okay, and then we're going to do our cross multiplication. So I'm going to go here, and -5 times 13 is -65. And then I'll have to pick a different color for the other one. 8 times -7 is -56. And that means that, oh, this is tricky because they're negative numbers. It means that -56 is actually larger than -65. It's closer to 0. It means it's a bigger number. So what that means then is that -7/13 is the bigger number. So I'm just going to erase this and replace it here with the less than. So -5/8 is less than -7/13. One other property that you need to know when you're working with rational numbers is the density property for rational numbers. What that says is between every pair of different rational numbers, there is a rational number. There's actually an infinite amount of rational numbers, but we're not going to get that far into it. You're just going to need to be able to find whatever they're asking you in between two different rational numbers. So here's an example. If a and b are both rational numbers, and a is less than b, then the number halfway between them is found using this formula. A plus 1/2 of the difference between b minus a. So that's asking if something is halfway between. If you're asked to find a number that is 1/3 of the way between, then you would just change the fraction. So you would do a plus 1/3 of the difference of b minus a. Here's another example. If you were asked to find a number 3/4 of the way between two different rational numbers, then your formula would look like this. And so forth, etc. So using these formulas, you should be able to answer any of the following questions in the book. Example 4 in the book asks you to find a rational number halfway between the numbers 3/4 and 5/6. All you're going to do is you're going to take your formula from before to find something halfway, which looks like this. And then let's label them. We'll call this one A, we'll call this one B, and then we'll just fill in. So we have 3/4 plus 1/2 of the difference of b minus a. So in order to do that, what we need to do is, if you remember from example 2, we have to turn 4 and 6 into a common denominator, least common denominator. And then the smallest number that they both fit into is 12. So what we're going to do is we're going to put both of them over 12. We times this one by 3 to get 12, so this one is going to be 9/12. We times this one by 2. This one's going to be 10. Actually, if you are paying close attention, you'll realize I just did that wrong. They should actually be switched. Like this. Because B should be here and A should be here. So now I've gone ahead and I've copied this over to this next slide so we can continue our work. So this is going to turn into 3/4, plus, oops, let's make that look a little nicer, plus 1/2 of 1/12, which will turn into 3/4 plus, now if we multiply these, 1 times 1 is 1, 2 times 12 is 24. Okay, so we have a simple addition problem now. Again, we need to find the LCD of the denominators that go into 4 and 24. And 24 works. So let me just change the color here. So this one is going to turn into, we have to times it by 6 in order to make 24. So it's going to be over 24. And then 3 times 6 is 18 plus 1/24, which equals 19/24. And so this is the number that is halfway between the original of 3/4 and 5/6. So that's our final answer. Looking at all these examples, you should be able to do all of the homework in Chapter 11, Section 1. Thanks and good luck.